So in this video, I will be covering the entire workflow for using the Mimics Innovation Suite to create a heart model for 3D printing, starting from segmenting the Dicom images up to exporting the STL file that is sent to the printer. Now there's a lot of different ways you could go about creating the model, and the best workflow will really depend heavily on your images, what you want the final model to look like, how the model will be used, and even what printer or printing technology will be used to create the model. So the more of this information you have at the beginning, the more you'll be able to reduce unnecessary work. What I'm going to show in this video is a pretty general workflow for creating a single colored heart model that you may find you need to tweak a little bit depending on your needs. So I've already imported a contrast enhanced CT of an adult heart. And one of the things that can help reduce the time it takes to segment these models is obtaining good images. It makes it a lot quicker if you get images that have a high resolution in isotropic or nearly isotropic voxels, as well as good contrast and even contrast in the region that you want to segment. To start my segmentation, I'm going to go to the segment menu and choose thresholding. And so I'm going to leave the upper bounds of my threshold range all the way to the top. And then I'm going to drag this slider for the minimum value to try to find the value where I'm going to be capturing the blood pool, but I don't want to go too far where I'm going to start bleeding out and connecting structures that aren't actually connected. So maybe about here, and you can scroll through your images to make sure it's accurate. And you might even get some areas like this where this pulmonary vein and pulmonary artery are bleeding into one another. But I bet if we tried to increase this threshold, this minimum value to break those connections, once we finally break them, we're going to start losing some of the other blood pool, and we don't want that. So I'm going to move this minimum value back down to about where I had it, and it might just be inevitable that you get some of these false connections that you're just going to have to manually touch up in your segmentation. So I'm going to go ahead and hit apply. And we can turn on the 3D preview to get an idea of how our first mask segmentation came out. And now the threshold is applied to the entire data set, so you can see we got the spine in there, part of the sternum, and so we'll want to remove that from our model. And to do that, I'm going to use the region growing tool. And this tool works, I'm just going to click on the heart, and it's going to place a seed point where I click and expand out to any of the connected voxels. And since we got lucky and the spine and the sternum weren't connected, the new mask it created just has the heart. And so if your images, you try using the region growing and you still have the spine or some other structure still connected to your heart after doing the region growing, you can use the split mask tool to split off the heart from those other structures, and you can check that tool out in another video on my channel. So at this point, we'll probably have to do some manual editing here to touch up our initial segmentation, especially in like this area that I found earlier where the pulmonary vein is connected to the pulmonary artery. And so to manually break those connections, I'm going to use the multi-slice edit tool from the segment menu. And so I like to work on the axial plane, and I'm just going to take this brush and start marking the area between these two vessels. And you'll notice with this tool I can skip however many slices I want. I'm usually just skipping a couple at a time. And then when I'm done marking all the way through, I'll use the interpolate feature to fill in those slices that I skipped. And so I'm done with my markings. I'll hit this green interpolate button, and then I'll scroll back through that area to make sure I'm happy with those markings. And if you want to touch up any areas, you can. And then I'll make sure my operation is set to remove, because we want to remove these highlighted voxels. And then I'll hit apply. If I hide my original mask, you can see they're no longer connected. And so you might have to do this in other areas of the segmentation, like this area where the artifact is bleeding into the pulmonary artery. I'm not going to take the time to perfectly clean this up for this video. So I'm going to move on, and maybe another thing we might want to do is remove these distal pulmonary veins. So I'm going to go to the segment menu and do the edit mask tool, because I'm just going to remove these in 3D. So I'm going to change my brush type to lasso, set it to erase, and then I can just draw a shape around these pulmonary veins and arteries to remove them. I'll do the same on the other side. I'm not worried about getting every little bit, because we can do another region growing operation, and maybe I went too far on the right side, so I'm going to hit Control Z to undo that. Now it's really just how much of these vessels you need in your model. Obviously, the less you have, the cheaper the model will be, because the less material you'll have to use. But you don't want to cut away any details that the surgeon or whoever's going to be using this model might want to have. So I'll maybe go with something like that, and then I'll do another region growing operation to remove all these floating pieces left behind. And so once you're happy with your segmentation, the next step is to calculate a 3D object using the Calculate 3D under the Segment menu. And so make sure you have the right mask selected, and then Optimal Quality, and then you hit Calculate. And this is where we're going to go from our mask segmentation to an actual 3D model or STL file. So once that's done calculating, you can go ahead and rotate the model around, check it out, make sure there's no errors and everything looks good. If you do see something that's wrong, you can always go back to your mask segmentation and recalculate your 3D object. So I'm going to go ahead and move on to the next step, which is to export this out to 3matic, which is the sort of like a post-processing software for STL files, where we'll smooth this out, clean it up, and hollow it out as well. So once that's loaded into 3matic, the first thing I typically do in 3matic for these heart models is I'll do what's called a wrap operation. And that's going to be found in either your Fix or your Design menu. And so for my entity, I'll choose the heart. And what this tool is really doing is doing like a shrink wrap around your part. So that's going to do a couple things. It can close in any holes on the surface of your part. It can also smooth it out. And also it can be used to remove any of the internal shells in your model. So it's going to make it a watertight and easily printable file. So I'm going to keep my gap closing distance set to 0. And then my smallest detail, I'll probably use 0.75 for this heart. When choosing this, I typically use the memory estimation. Try not to go too high, above 600 or 800 megabytes. It might take quite a while to calculate, unless you need that sort of level of detail. And what this parameter is really choosing is basically we're going to lose any details that are smaller than this value that I set, and it's in units of millimeters. So any details that are smaller than 0.75 millimeters will be lost. You can lower this if you want, and that's fine. You'll just end up with more triangles describing your part, and it'll take a little longer. Whereas if the higher you increase this, the more smooth your model will be, but also the more defeatured it can get. So I'm going to hit apply and let that calculate. So once that's done calculating, you'll notice we have a new part in our object tree, the cyan1_wrapped, and it's overlaid on top of our original model. So if I right click and hide our original, you can see it's smoothed out quite a bit and just looks a little nicer. So from here, if we wanted just a model of the blood pool of the heart, we'd probably be just about good to go. But let's say we want to take it a step further and actually create a hollowed model of the heart. To do that, I'm going to go to the Design menu and choose Hollow. I'll choose what entity I want to perform that on, and that's going to be the wrapped model. And so what we're going to do is we're going to hollow it to the outside. So this outer surface here will become the inner surface of our hollowed model. And we can just give it a uniform wall thickness. So I'm just going to put that at 1.5 millimeters. When choosing this distance, you got to keep in mind what sort of printing technology you'll be using for your heart. If you're going to be using a more flexible material, you might want to bump this up to 2 millimeters or so. Otherwise, it's going to be more likely to tear or rip. If you're using a more rigid material, you might be able to get by going all the way down to 1 millimeter wall thickness. And I'm just going to use the same smallest detail that I used in my wrap operation of 0.75 millimeters. And I'll hit apply to let that calculate. And so you can see it sort of bubbled the model out here. In certain situations, you might not want just a uniform wall thickness. Maybe you want the actual myocardial thickness around the ventricles. You can see how in a lot of adult hearts, with just a small wall thickness of 1.5 millimeters, the ventricles might actually look separate when really this is going to be filled with solid tissue in actuality. So I'll do another video walking you through on how to add the myocardium to your hollowed model. But in other cases, maybe you're just interested in the intracardiac anatomy and you don't really care about the wall thickness. So in those situations, you wouldn't really have to worry about adding the myocardial thickness. And so after we've hollowed it out, I'm going to go ahead and under the Finish menu, choose the Trim tool because we now have to trim these vessels open. And so this tool works by just left-clicking different points, and you can draw a shape around the area that you want to remove. And so as long as it's set to remove inner, it's just going to remove all of this material in here when I hit apply, and that will trim those vessels open. And so cutting your model and how you do it really is going to depend on how or what you're trying to get out of the model. So maybe if you're interested in outflow tract, you might want to cut off the apices of the ventricles. And this is really where you're going to want to communicate with the end user of the model. So you can see that cut there. And if you get floating pieces like this left over, one trick to help get rid of those is to use the Mark Shell tool to mark the main shell of your heart. And then you can go back to the Mark menu, choose Invert, and hit Delete on your keyboard to delete those floating shells there. Now let's say maybe instead of just cutting away the ventricles of the heart, maybe you just want to cut them into a separate piece and print this model in 2 separate pieces. You can do that using the Trim tool as well. But instead of choosing Remove Inner, I'm going to choose Preserve Inner and Outer. And I'll make that same line. Hit Apply. And you can see we now have 2 different parts. So I can show and hide the 2 separate parts. And they can be printed separately, so they can be added or removed. So you still keep the entire heart model, but if you want to get a better view of maybe an outflow tract or the AV valves, you can do so. And for these leftover floating shells, if you still want to keep them and not just delete them, you can mark that shell using the Mark Shell tool. Right click on that, go to Separate, Move to Part, choose Existing, And so we'll choose the other part to move that shell to. Hit apply. So if I hide this shell, show the other part, you can see it's now part of that. And maybe we want to move these coronary arteries back to the other part as well. And so when cutting your part, you also want to keep in mind what sort of printing technology you'll use and what sort of support material or where the support material will be laid. Because you want to make sure, especially with these hollowed parts, that you're going to be able to access all the areas where support material will be placed, and so you can remove that support material very easily. And you might have to make a few additional cuts just to be able to clean out all of the support material once it's printed. The next step after cutting your model open would be to send it through the Fix Wizard. And so I'll select my part, go to the Fix menu and choose the first option, Fix Wizard. Make sure full analysis is checked, and then you can just hit follow advice. And this is going to analyze your part for any issues that it might have, such as inverted normals, intersecting triangles, and it can automatically fix those if you just hit follow advice. And I'll just keep hitting this until it fixes all these issues. And so at the end, you might have multiple shells if you're supposed to, and you might also have some overlapping triangles. Don't worry about those. Your part will still be printable with the overlapping triangles. And once your part is fixed, then you can go ahead and go to File, Export STL, and export out your STL to be sent to the printer. So this was a quick run through of a general workflow to go from start to finish on creating a 3D heart model for printing. It's definitely not the only workflow, and you might have to make some adjustments and very likely spend some more time doing some of the manual editing. But hopefully this will provide a good basis for you to get started, and thanks for watching.